Hi and welcome to this video about getting the Windows numeric version. So every Windows version has a numeric value. It consists of four numbers: a major version, minor version, a build number, and some kind of revision that is sometimes important. And so how do we get these numbers? And to begin with, why would we want to get these numbers? Well, sometimes you might be leveraging some kind of feature, or at least you want to leverage some kind of feature that you know exists in only a certain version of Windows and up. And so you need to know what you're running on. Now, I would say up front that the numeric versions of Windows are kind of confusing. The numbers are not really what you would expect. For example, the Windows 8 version number is not 8.0, it's actually 6.2. And for Windows 7, it's actually 6.1. For Windows 8.1, it's actually 6.3. And you might be wondering why this is the case. And the reason has to do with the compatibility, which is something I will not cover in this video. What I want to focus on this video is how to get these numbers. And you might be thinking, how difficult can that actually be? It's just getting these numbers. And so let's see what happens with the version number. So here's one way to get that without writing any code, like opening a command window. You see that I can write, I'm running here a system that has the version number 10.0.19045 point something. And so I'm running Windows 10 apparently. At least that's what the numbers lead me to believe. And the build number is 19045, and there's some revision there. Okay, that's one way to go about it. Another way is to use a tool called WinVer, which is a built-in Windows tool. If you run that, you can see that there's a little dialog box here and it says the OS build number is 19045 and the same revision number. So it's also basically saying the same thing, because this build number is unique to a particular Windows version with a particular service pack or a particular update. So well, to be more precise, these two numbers together are providing exactly that detail. But this is Windows 10. Obviously, I see that in the title. We don't see 10.0 here as the major minor version numbers, but we see this is Windows 10. If I take a look at the Windows 11 machine, for example, and I open command window, here's what we get. We get that the version is 10.0.27954 in this particular case. And so that might seem strange. Shouldn't it be really version 11? If I go ahead and run WinVer here just to verify, I am running Windows 11 on this virtual machine and the build number is indeed correct, but the major version number hasn't changed. The reason with that, again, for that has something to do with compatibility, but just know that Windows 11 is still 10.0. It also kind of hints to the fact that Windows 11 and Windows 10 are not really that different. Windows 11's kernel is built on Windows 10's kernel, so there's just some additions there, of course, but still, fundamentally, it's the same operating system. Most of the changes we see in Windows 11 are superficial, user-facing features like the new taskbar and start menu and things like that, which you may or may not care about. Anyway, I want to get to that information, so how can I do that? So let's go ahead and try to write some code to get that information. How are these applications getting that information? So let's create a simple console application here. Let's call that WinVersion or something, and see what we can come up with. So for C++, the old way of doing things to get the version number is using a function called getVersion.ex. Let me include some headers first. We have windows.h as usual and stdio for printf. Let's try to call the getVersion.ex function. So here's getVersion.ex. You can see it accepts a very long structure. We can, of course, just type it. That's always version info w. Something like this. So let's call that v. Very easy. And if we look at the data structure itself, you can see there's a size parameter here that we need to fill out up front. Let's go ahead and just fill it up, just by using the size of the structure. And then let's try to call this function. And if that works, then we'll get here the build number, major number, minor number. So we get most of the details from this function. So let me try to go ahead and build that first. And you can see that it doesn't compile, and it complains that this function is now deprecated. So you shouldn't really be calling this function. And so if we go to getVersion.ex, so you can see this is the function, and there's a message here for deprecation. So this means this function shouldn't really be used anymore. It's still defined in the sense that it still needs to compile maybe for older versions, or at least it definitely exists, but we shouldn't really use that. And there are some macros here we can use to try to bypass that. We can do that actually. We can try to bypass that. But the first question perhaps is, why is this function deprecated? And the reason has to do with the version numbers. As I mentioned earlier, the version numbers don't necessarily make sense according to the operating system that you expect to get. So actually relying on version numbers is probably not a good idea. You typically don't want to do that. And so in order to check the version number, you don't really want to look at the actual number, but instead you want to ask more general questions. For example, am I running on Windows 8 or later? Am I running on Windows 10 or later? And things like that. So for this purpose, there are functions that we can use, but just to prove a few things, I do want to call getVersion.ex just to prove something. So instead of going ahead and just trying to circumvent these deprecation by using various macros, I'm going to go and use C# here. And the reason I'm using C# is because in C#, well, in the .NET framework, really, there's a way to get the version number by using some C# .NET properties, and they call getVersion.ex behind the scenes. So I would like to do that to demonstrate the problems with the version number, as I mentioned before. So I want to just take the normal Windows C# application. I don't want the .NET Core thing, but still it's very difficult to sometimes work with this new project dialog nonsense. Let's go ahead and give it a shot anyway. So let's call that CS and WinVer. And I don't want containers. I don't want all these nasty stuff. I just want Windows. Let's see if that works. Okay, so we have console write line. That's great. We can start with that. So let's see if that works. So first, let's go ahead and see if we have the environment class, and we have an OS version here. And there's a version string. We can just go ahead and display the version string. So let's see. Let's give it a shot. So let's take this application as the starting point. Let's press Ctrl F5. And once we run it, we get this same, very similar information that we've seen in WinVer. That seems to work pretty well. However, that's because this is a newer framework that knows about Windows 10, has some internal logic to get the real version number. Let's go to the real, or the fundamental console application that uses the .NET framework, the framework that is built into Windows. It is part of Windows and not necessarily something that I've installed as the new .NET, just to prove a point. So let's call that CS WinVer 2. You can select any .NET framework I want, doesn't really matter. So here's the classic version here. Let's do the same thing, environment OS string, sorry, OS version and version string. Let's run this thing. And here's what we get. Sorry, running the old one. Let's run this one. All right. So here's what we get. We get the version saying that this is Windows NT version 6.2.9200. So in fact, this is exactly the version for Windows 8. And that's what we get by default. This is for compatibility reasons. Again, the reasons exactly why the compatibility here matters is something I won't be discussing in this video. But definitely I'm getting a wrong result. And this is what getVersion.ex actually returns. So it is returning something which really is wrong. In fact, for anything that is Windows 8 or later, it's going to return 6.2. Even if I take this application, try to run it on a Windows 11 machine. So let me just go ahead and do that just for fun. So let's grab the particular application, so CS version 2, bin debug. I'm doing that on my other screen so we don't get distracted. Here's my VM. Let's just open something like ctest and paste it here. So here goes. Let's run this thing. And you can see it says the same thing. Even though I'm now on Windows 11, we still get the version of 6.2. And again, this is a lie provided by the getVersion function because of compatibility concerns. And so the question becomes, how do I get the real version number if I'm using, say, .NET? Or how do I get the real version number in C++? Because right now I get just deprecation here, which I don't like. Let's start with C# and see how we actually can get that correctly. So the way that works today is by including something called an application manifest. The application manifest is not a new thing. It has been created in the Windows XP timeframe. And the idea here is that you can provide an XML file that then is embedded as a resource into an executable that has various settings which are being respected or used by the runtime, by NTDLL and other APIs. And so we can do that in this project. Let's do an add item and look for a manifest or something like that. So you can see there's an application manifest we can add, and this is Windows only thing, obviously. And you can see there's lots of stuff here. There's some defaults that we get, and some of that is related to UAC elevation, all these kinds of things. We don't care about that, but this particular part here we do care about. So the idea was that Microsoft has generated a GUID, which is unique by definition, for every new version of Windows that came out. And what you would do, instead of just calling getVersion blindly, you need to specify in this manifest what kind of operating system you're aware of. So for example, if I'm aware of Windows 8.1, I'm going to comment this out. And this was the GUI that was selected for Windows 8.1. I'm going to run the application again, the same C# application. Here's what we get. Now we get 6.3.9600, which is exactly the version of Windows 8.1, because now we're telling the runtime that we understand what Windows 8.1 is. We are aware of that. Application was written maybe a few years ago, where Windows 8.1 was the latest at the time. So it's not possible to guess a future GUID. So I can't try to get a Windows 10 version if the application was written years ago, before Windows 10 even existed. So if I'm aware of Windows 10, of course I'm aware, I can comment out this GUID for Windows 10 and then run this application once again. And now we get the true version number of Windows. That's 10.0.19045. That's the build number. So that's one way to get the real operating system version if you're using getVersion either directly or indirectly. And so in our C++, and by the way, we can, well, one thing you might be wondering is what happens with Windows 11. I mean, we have Windows 11 today, so why don't we have any GUID for Windows 11? Or maybe there is a GUID, it's just not provided here. And the answer is that we don't have a GUID for Windows 11. And the reason is probably because Windows 11 is really Windows 10 with some extras. So the version number wasn't really incremented to 11. And so the same GUID applies. Which begs the question, so how do you differentiate between Windows 10 and Windows 11 if you care about this differentiation? And the answer is that you look at the build number. The build number is going to be at least 22,000 for Windows 11. So here's an example. Let's just copy this application again with the updated version with the manifest and see what we get. You can see that we get now the true version of Windows, as we've seen here in the command window output, and the build number is 27,000 something, which means it is Windows 11. So the way to identify is by looking at the build number, and if it's 22,000 or higher, this is Windows 11. If it is lower and still the version is 10.0, then this is Windows 10. That's the way it works today. So there is no GUID for Windows 11. So going back to the C++ case, how do we get the version here if getVersion is not something we can use? What can we do instead? And so the official way of doing that is by using a bunch of functions or macros called version helpers. And the idea with version helpers is that I shouldn't really be using actual numeric values, but instead making checks. For example, I could do something like if is Windows As you can see, various options here like 7, service pack 1 or greater. So we have these booleans that I can check. So for example, if I'm interested in a feature that is only available in Windows 7 Service Pack 1, I can use this thing to check whether that version is the one I'm running here right now. So I don't have to deal with the actual internal version numbers and the fact that Windows 7 is actually 6.1 and all these kinds of stuff. We don't need to know that. So we can hone in on the appropriate version just by doing these checks. And of course, we can have multiple checks. For example, if you're interested in Windows 8.1 exactly, not or greater, we can say something like, is Windows 8.1 or greater, and not is Windows 7 or something. And so we can kind of make this combination of tests to hone in on a particular version if this is what we want to do. That's the official way of doing things, but even that will not actually work as we expect because it still requires a manifest. For example, if I just do something like this, if this is Windows 10 version or greater, Windows 10 or greater, then let's just display something like Windows 10. Very simple. So let's make this the startup project here and run this thing. And we get nothing, which means it doesn't think this is Windows 10. It thinks it is Windows 8 as before. And that reason for that is still the manifest is being respected. And since our C++ application has no manifest, the default is Windows 8 if we are running on Windows 8 or later. So we can add that manifest as well. I can use get add new item, and there is no manifest here that we actually get properly. This package manifest is not the same thing. It is just it's a manifest for other kinds of applications. This is not the XML that we're actually looking for. And so we can try to get something like an XML file or something like that, which is the closest thing. So we can take an XML file, we can just give it a name. We can give it any name technically, but if I call that app.manifest, I actually get support from Visual Studio here that understands that as the actual manifest. So now I can go ahead to my C# application, just do some copy pasting. So I can go ahead and just copy all that stuff here. That should be fine. Here it goes. I just copied everything, and then of course we can change things if we wanted to change anything, but in this case what we care about is these GUID, and now they're already enabled here. So let's try it. Let's just build our C++ application and see if the linker understands that this is supposed to be a manifest. So let's run it again and see what we get. So it's loading symbols, but you can see it is identified that as Windows 10. So we do get the correct information if we ask nicely. Ask nicely means using the version helper functions, but also require the appropriate manifest. Without a manifest, these functions will continue to lie, just like GetVersion EX does. How about another way? Maybe there is another way to get the Windows version. Well, there is a function called RtlGetVersion. And this function is documented in the Windows driver kit and it looks something like this. And it allows us to get the version number, the real version number, without anything interfering with this function. So although this is function that is documented in the kernel, technically the same function exists in NTDLL, which means it is also implemented in user mode. So we just need to provide this kind of structure here. And so one way to go about it is just doing some copy pasting here, or going to the Windows kernel headers and copy pasting stuff from there. So this is what that structure looks like, and the function is called RtlGetVersion. So if we again go back, we'll see that there's actually a type there behind the scenes. There's an anti-status here, and this anti-sys API is just a macro indicating this is an external C, that is a C function, not a C++ function. And so anti-status is just the return value for kernel functions, but also for anti-DLL native API functions. So that's going to be just a simple integer actually. So we don't actually have to get to the real types or the exact name of names of these types. So we can get away with doing something like this and expecting a pointer to one of these structures. So let's just go ahead and take one. I can, of course, use the other type devs there. It doesn't really matter. And then we can try to call these functions. So we're going to create this OS version info W structure. Let's call that V again. You can see it actually looks exactly like the structure we provide to GetVersion.exe. In fact, it is exactly the same structure. So I actually didn't have to copy all that. I could just use the same structure because the actual function has no idea what that actually is called, and it doesn't really care. But just for completeness, we will write it in this way. And now we need to call this function RtlGetVersion. And we can pass this V thing. And we expect in V to find all the details. So we can put a breakpoint here maybe and see what we get. Okay, let's give it a shot. So there's a structure redefinition here, and that's in fact because it's the same structure from GetVersion.exe. So in fact, it's providing duplication here. So we don't want to use that. Let's just use the structure that we already have. So the compiler is happy. Just to prove it's actually the same thing. We get an unresolved external because this function is in anti-DLL, and by default it's not the import library is not provided in new console applications. We can just add that by using a pragma. You can also do that in the project properties, but let's just add that in the pragma. So because anti-DLL.lib is provided mostly by Microsoft, so it's not fully complete, but it's complete enough. And now it's linked successfully. Of course, we can also use load library and get a proc address to get the function address dynamically. Okay, so let's give it a shot. Let's run this. And you can see that if you look at V, it actually succeeded and we get the appropriate numbers. Let me just remove the hexadecimal here so it's easier to see. So you can see this version 10.0.19045. Now you might be thinking, okay, so that's nice, but does that depend on the manifest? That's an interesting question. So in fact, it doesn't. So that's the nice thing about this function. So if I remove the manifest, just remove it from the project and run this again. So you'll notice that the result we get is still correct, which means this function has no dependency on the manifest. But is Windows 10 or greater still depends on the manifest. If I try to go over that statement, it doesn't go into Windows 10 because it still thinks this is Windows 8. But RtlGetVersion is immune to that stuff, which is nice. It just gets the real number and that's it, we're done. So this is the way to go about and getting the Windows version if you really want to from C++ without having to bother with that manifest, which might cause you some headaches, or you don't need that kind of extra complexity. So this is how you get the version numbers in C++. That's the best way to go about it. Technically, there's yet another way, which is using a shared data structure that, I mean, it's shared in the sense that it is mapped to the same address in every process. This is known as the K-user shared data structure, which is partially documented by Microsoft, and the version number is there. That structure is for read-only access from user mode. You can't write to it, you can change anything in there, and there's lots of details there. As one of the details is the OS version number. I'm not going to show that because the video is already too long. If you're interested, look in my Windows Internals Day 1 course on TrainSec, and you'll see all the details there. I also explain there why the version numbers are the way they are. I mean, why are they not following the logical versions of Windows? Why is Windows 8 actually 6.2 and so on? I explain that in that course. But feel free to play around with these manifests and other ways of getting Windows versions.